All right, we're entering a new unit, and the focus of this unit is to be able to solve a system of linear equations. All right, so there are basically three techniques that we're going to look at. First off, well, what did I mean by a system of equations? And you can see the word here. And when I say a system, that's a set of two or more equations together that we're trying to solve. And so what does that mean? Well, what the solution is an ordered pair that makes both equations true. And so typically on a graph, we're looking for where two lines would intersect, because that intersection point would be the solution to the system. Okay. Well, three methods that we're going to learn are graphing method, substitution method, and a method called elimination. So today we'll look at graphing. All right, so first let's practice what does it mean to be a solution to a system. And as I said, if you input this point into the equation, it should make the equation true. But it has to make both true to be a solution. All right, so let's see how that looks. Let's plug in -2, 3 into this one. All right, so plugging in the point, and we get 5 times -2, that's -10. 3 is a y coordinate, so that goes where the y is. So -2 times 3 is -6, so -6. And we're checking, is that equal to -16? And -10 and -10 do add up to -16. So that's a check. Okay, and then we plug it into the second equation. All right, same thing. All right, so make sure you put it in the right spot. 3 is a y coordinate, so 3 goes here. 3 equal to x plus 4, so -2 plus 4, which is 2. And 3 is not equal to 2, so that's a false statement. And therefore, we got one of them was right, one was wrong. You need them both to be right. So -2, 3 is not a solution. Okay. All right, let's try the next one. Again, we're using the same ordered pair. So I plug it in. I'm putting -2 in for x and 3 in for y. All right, so -2 plus 3. Is that equal to 1? True. Check. Let's try the next one. Plug it in. 3 is the y coordinate, so it's 3 minus 7 on the left. Is that equal to 2 times -2? All right, so what is this? -4 equal to -4? Check. All right, so it worked in both equations. Therefore, it is a solution. All right, so let's see how we use the graphing method to actually find that solution. All right, so we're going to graph these two equations and see if they intersect anywhere. So let's go ahead and plot them. We're going to need to plot a y-intercept of 5 and a y-intercept of -1 on the same grid. So I'm going to draw my y-axis just kind of in the middle of the problem there. And I'm going to need 5 to fit. So I'm going to let me put 5 here, then that'd be 4, 3, 2, 1, 0, and then I'll be able to fit -1. Okay, so I'll put my y-axis there. Excuse me, that's the x-axis, right? Horizontal axis? Okay, barely see it. I do like to use colors when I use the graphing method. I graph each line in a different color. That way it distinguishes it from the other one and from the axes. All right, so I'll do the first line in green. All right, so 5 in the first line, my y-intercept is 5, and the slope is 2. 2 over 1, right? So we're going to go up 2 and right 1. Up 2, 1, 2, right 1. Kind of puts me there on, that's a little bit close, so I'm going to have to go the other direction. Down 2, left 1. Down 2, left 1. And repeat and just get all those points. Now this is an equality, so it's a solid line. I'm going to just connect all those dots. No shading like we did with inequalities, right? So it's just an equation. We just draw the line. All right, and now we're going to graph the second one. We have a y-intercept. So the y-intercept is -1, and m is -4 over 1. Okay, so let's graph the y-intercept. I'll use red, -1, and slope. That means top number is negative, so we go down. Bottom number is positive to the right. Down 4, right 1. 1, 2, 3, 4, right 1. I'll have to reverse directions. Up 4, 1, 2, 3, 4, left 1. And notice I fell right on the other line. 1, 2, 3, 4, left 1. So there's my line up points. Connect them. There we go. And this right here where they intersect, that's my solution, and which is the ordered pair. So looking at my axes, my origin, this is at -1 for the x coordinate, and 1, 2, 3 for the y. Do it again. And let's get our values. So we have a slope, y-intercept, and the other line has a slope of 1 and a y-intercept 3. Whoops, not showing you my work. Okay, so graph both lines and determine where they intersect, if at all. Okay, I'm going to graph y-intercepts first, so I just want to fit them. The high point is 3, so in green I'll put 3 right there, and then my x-axis would have to be, so if that's 3, 2, 1, 0, so my x-axis goes on 0. Not very bright. Okay, x-axis, y-axis. All right, so my other y-intercept is -1. Put that one in red. Okay, so the first line, y-intercept of -1, the slope is +1. Remember that it's 1 over 1, right? So up 1, right 1. Up 1, right 1. Up 1, right 1. So you see how they're lining up. Go the other direction. Connect the dots. All right, y-intercept of 3. My slope is 1 again. So up 1, right 1, etc. Down 1, left 1. Connect the points. All right, so these two lines do not intersect, and they never will. It's hard to tell sometimes. You know, eventually you could have lines that are gently sloping towards each other, and eventually they connect up. We just don't fit it on the paper. But in this case, the two lines have the same slope. So they will always go in the same direction, even though one's a little higher up than the other. They're just going to continue in this direction forever. And so that's true whenever two lines have the same slope, they will be parallel to each other. So there is no solution. They do not intersect. So we'll write that. Lines are parallel. So there is no solution. Let me put it together on the same line. I'll circle that. If two lines don't intersect, parallel lines never intersect. So if they don't intersect, you can't have a solution point. You must have the two lines connecting up at least once. Can two lines connect up more than once? Question to think about. All right, let's graph these two. I can see the first one's in slope intercept form. The other one is in what form? Okay, so that's standard form. So I'm going to use the intercept method on that one to graph it. Okay, so the first one, what information does it give me? My y-intercept is 4, and the slope is 3/5. So let's graph that. I need to be able to go up to 4, so let's put it down here. So x-axis, y-axis. All right, so let's plot the first line is y-intercept of 4, slope of 3/5, so up 3, right 5. 3, 1, 2, 3, 4, 5. And reverse directions. Down 3, left 5. 1, 2, 3, 1, 2, 3, 4, 5. That's about all I'm going to fit on there, so that's good enough. Oops. Okay. All right, and so let's take a look at this one. Okay, I'm going to use the intercept method. So I'm essentially just going to cover up a letter. So for my x-intercept, I want to cover up the y value. So if I cover up the y, I get x equals -4. So that's I don't have to solve anything. It's pretty simple. And then my y-intercept, I zero out the x, leaving y equals -4 as well. So they both have the same intercept. Let me do that in another color. So -4 for x, 1, 2, 3, 4. 1, 2, 3, 4 is my y-intercept. So there's my line. And so we can see that they have a solution right here. And that is located at 1, 2, 3, 4, 5 at -5, comma, +1. Okay? All right, so just a different method. So it's time for you to practice.